Bismillah ar-Rahman ar-Rahim. So, first of all, I will just briefly go through the WaterGem and give you some introduction to that, to the software. So, first of all, when you start a WaterGem, it's a good practice in order to you to give the info about your water supply system design or whatever you want to design. So for example, we are designing a water supply system and engineer some information about you, which area. Similarly, for example, we are working for a CSS consultant. So that type of information should be provided. It's viable and so good. Other step after before starting a design, you should properly manage the options of the water supply system, WaterGem. So in order to manage these options, you can open it from the tool tab. Similarly, for the by going into these options more and then selecting options, and you can also open it by clicking this arrow and the tools tab, and you can also open it by the option. Uh, so so basically these are different tabs showing the different options of the WaterGem. Before you want to you start a design, so you should properly prepare these options in order to properly design the water supply system. So global backup levels means that, for example, if you designing a water supply system and you save your design, your work, so how much backups in the form of .bak, in the form of format of .bak, it's created and save it. And for example, if the model deleted from you, and you can easily able to restore that from the backups it had the WaterGem created for you. And show recent hydraulic models is basically, for example, if you are working for the different supply network and you have designed different water in a different files in a then it shows the recent file that have used up to a 25 level. Similarly, you can also compact database after the, for example, if you save the files after 10 iterations, then it can compact the file after 10 iterations that you have saved. Similarly, you can open the status pane. It's basically the status pane. You can that open from here and remove from here as well. Welcome page is basically when you start the water supply WaterGem, then you provide you the show welcome page at the startup, zoom, extend on, open. Similarly, you can change the background of your workspace. You can change it to the different color like that. So you can change the background color. You can change the foreground, for example, when you create, let me change it again. For example, when you create the water supply system, for example, when you lay out the water supply network, so the foreground color is basically the colors of these pipes and joints. You can change that as well. So based upon your choice, you can change it easily. And the selection, so for example, when you select the pipe, so the color becomes red, so you can also change that color from these options. Read only background and read only foreground is basically the, for example, it's a flex table, provided the information about the pipe, the pipe flow node, and different stuff like that. For example, it's a table. So these are basically the read only tabs or the columns where you can't change only any changes. So the color of that you can also change it that as well. Display inactive topology. Mostly For example, you have created different scenarios. I will show you that practically, but before showing you that, I want just to show you that what type of color, how what that this anecdote topology means. And for example, you created two different types of the alternative having different topology. So one have a pump and other have a disabled pump, inactive temp pump. So the in a scenario on or in an active topology where there is a pump inactive, so it will be shown to this color. You can change it easily from here as well. Oh, and similarly, these are the different handle size in pixels and the selection line width multiplier. You can change that. You can, for example, if you increase the width of the a pipeline that here it shows, then you can change it from here easily. If you, for example, if you want to work mostly if you use import the model from a GIS, then we will use the drawing style of GIS. We cannot use CAD because you will see that it becomes very bulky and not properly aligned with each other when we use the CAD drawing style for importing a model from a GIS. So you can change that from here. Hydraulic model, for example, if you are using the identifier for mostly for the importing a model from a GIS, so we can use that. We can use the element identifier format like for ID only, label only. You can understand that well when we start the importing a model from a GIS. So you can round the length of a pipe from here. You can also, if you want to use the 3D length, for example, I want to show you that. Let me share the OneNote. Here's the OneNote. Yeah. Okay. So for example, you can use the 3D length of a pipe horizontal. If you know the horizontal length, for example, 3 feet or 4 feet, so the 5 feet you can use that length of pipe. For example, if you want to use that length of pipe, so you can easily use the by enabling the option of use 3D pipe length. Similarly for rank, for what type of scale you want to make your workspace for modeling a water supply network, you can also use a schematic diagram for schematic workspace, and you can use the symbol size multiplier. For example, if you want to increase the size of a junction, so I want to multiply with that, and also you want to increase the size of the text related to it, so you can easily do that from here. But it's only work for the CAD style. For JS style, it's constant, it do not work. So you can increase the text style and the symbol size easily through the options. Here from here you can easily, for example, if you do not want to align the text with the pipes, so you can also check and disable enable this option as well. For example, and also you want to do not to for example, if you want to check the pressures on each junction based on the by providing a color, then this option should be enabled by proper annotating these junctions. And similarly, uh, unit, it's a very important step before designing a water supply network. You should enable, you should identify, you should know about the water supply, the units that you want to design a water supply network. But in the context of unit, the WaterGem, it is very flexible. You can easily change the units. For example, if you know the values, for example, I want to show you it practically. That for example, if here's a pipe and you want to give the length of a pipe, here's a user defined length. For example, you want to define the length of a pipe, so it is in a meter. Recently it is in foot, and you have about the length of that pipe in a meter, so you can easily change from here the unit of that pipe and enter, for example, is a 10 meter. Okay, so again convert into the foot, so it will automatically multiply the multiplier, for example 3.28, and it will calculate the length of 5 input 5, and you can also increase the precision from here to, so you can get the value of proper precision, and around here you can also change the format. For example, you want to change the scientific format, it will show you in the scientific format. So it's very flexible, the WaterGem, is compared to the EPANET. So you will get to know, when you used to use the WaterGem, then you will get bored. You start to design water supply network in a EPANET. Okay. So it's a unit, so you can make precision from here as well. It's basically a display precisions. If you want to display the length of pipe, so it will give the precision about 5 decimal, up to 5 decimal places. So I will show you that as well, that how to manage it when I do it, when I will be doing it practically, that how to manage these precisions and the degrees and other things, stuff like that. So just use customary unit is good. Labeling, okay. If you want to label your water supply system, you can set it here prior to design of water supply. For example, here you can see that the P dash is taken the prefix, and the increment is an increment by increasing the number, by adding a 1 to it by adding every pipe. So it is incrementing at the rate of 1. So next for mean, for example, if you are there we have 3 pipes. If you want to create a 4th pipe, so it will have a prefix or the text of, or the name of that pipe will be of P-4. Similarly, for the length, for the lateral, for the junction, please mute your mic, Musa. So, you know, so you can manage these the annotation or the labeling of the each element of a water supply network. So you can do it for a junction, custom meter, taps, SCADA elements. You can manage these SCADA elements. For example, you have installed a water supply system. I can't do this because I haven't experienced this, because in Pakistan we have a SCADA system. So when I get to know, inshallah, we will be in a group. So we will, when I get to know about the SCADA elements, SCADA system, so I will share with you my experience, inshallah. So for the labeling purposes, hydrant, tank, reservoir, pump. So for these different type of elements, you can make prefixes and suffixes and digits like that. So it also show you the preview of these, that how the element will annotate or label when you create it in a workspace. The project wise, leave it here. Okay. The second step is that, for example, let's start the modeling a water supply network. For example, you can model a water supply network from here, from a layout as well, from separately using the pipe laterals and junctions, the hydrant, reservoir, tank. Hydrant basically used for the fire flow analysis, or by finding the fire flow demand at the junction, you can connect the hydrant to that junction as well. The customer unit, the tab, these can be used. That is, customer is basically used for the customer meter for finding the demand at junction. So the different methodology used for the assigning demand to each junction, we will inshallah we will discuss that in detail when we start a case study. I'm just going you through the WaterGem, giving you to introduction the different elements involved in the WaterGem. So you become familiar with these different stuff involved, included in the WaterGem. So you can design a pump. You can model a pump station, VSP battery. VSP battery is basically provided a variable speed pump. Mostly the battery is provided in order to amplify or de-amplify the speed of the pump when operating through the water supply system. Basically, mostly, I think I don't know about that. Mostly, the variable speed pump is not mostly using in our country. Mostly in the developed countries, the variable speed pump are using. So these are the different valves: the pressure reducing valve, pressure sustaining valve, flow control valve, the throttle control valve. So these are the different valves that can be used and have its own functionality in the model or a design of a water supply network. Similarly, the isolation valve, the spot, and is a transient analysis. Basically, we were stuck with the hydraulic part of the software, but I will try to conclude this as well, because the transient analysis is very important in order to design the water supply system. For example, if you design the water supply network and you don't consider transient analysis, the water hammering effect, so if you don't consider it, then the busting of pipe or the collapsing of pipe may occur in water supply network by not properly the closing of valve or directly. If, for example, in our countries, when electricity is gone, the light off, so due the suddenly the shutdown of the pump may cause the watering hammering effect in the water supply system. So that may greatly affect the water supply system. So these mostly the elements are provided: surge tank, hydropneumatic tank, air valve, mostly to mostly in order to reduce that type of failures in a water supply network. So isolation valve mostly are provided to in a water supply network in order to prevent the flow through the pipe, and mostly for example the water supply network consists of for different pipes and different area, different localities, mostly different terrains as well. So mostly at the lower terrain, the water supply, the pressure at the junction is very high, raises up to 100 psi, which may cause the busting of a pipe. So mostly you install a isolation valve from one side in order to reduce the flow from other pipe as well. Mostly in the case of, if, for example, if you provide a gridiron system, interconnecting of different type of pipe with each other in order to prevent the dead end system. So you can reduce the flow at that junction by providing a isolation valve, and also you can provide a PRV, pressure reducing valve, in order to reduce the pressure at that junction as well. So let's first of all I will model our water supply. For example, I want to model a water supply network. So I will go to this just in a while. Just be with me. For example, I want to let me I have found the CAD drawing from Bentley website. I want to add this as a background. You can go from background layers, right click on the background layers, new file, then browse it to the where you have saved that file. For example, in the WaterGem I have saved here, so you can manage that as well. For example, it's a meter in a metric, so you can change that to meter. You can change the symbol size, fill diamond, and you can change the transparency of that as well. So it's basically the CAD drawing. You can also load the CAD drawing as well, but the in CAD drawing it I think it do not automatically calculate the length. You should have the length of pipe. You should have enter manually the length of pipe. So I want to start model. So for example, I want to model a tank here. Increase size and change the unit. Okay, but the use specimen is very good. Okay, I want to increase the size of starting from a layout. For example, if you want to create a tank, then right click on a tank, create a tank here. For example, if you are here, you want to create a junction, right click, create a junction here, and then go to tracing the background map, create a junction here. Similarly, junction here. For example, here the bend, you can also provide a bend. Just right click on a bend, click here, and again here if you want to provide a junction, then click a junction as well. Right click if you want to finish the drawing, just click on done. Again, if you want to start a drawing, just click here. And similarly for here, want to provide a bend, click, done. I want to show you how to provide a bend in another way. Okay, if you want to provide a bend in a pipe, just click a pipe and bend, add bend. It will create a bend for you and just make it properly arranged. Okay, so you can see here that we can not see our model properly. You can change the color of the pipes and junction easily just by making it to the black. And another way, we should also increase the size of the text. And I want to reduce the transparency of the background map. So I will go to the right click on the scale network matrix and click on the edit. And after that, I want to reduce it to the 60% transparency. So you can see that the background map can be, the transparency can be reduced easily. Okay, let's go through the properties of tank. Okay, so these are basically the properties of tanks we usually when we design a tank. So mostly let me go through this. One note, I will show you that what are the خالد भाई स्क्रीन बदलो दोनों कारी का ना
जी अफकारी
for example if you add the properties of the tank, so here it is elevation maximum, elevation initial, elevation minimum, and elevation base. So I want to explain you that what and similarly the elevation here. So I want to explain you that what are these functions or properties.
مباشر से माइक लग जो कई तो आवाज दे कलर कलर लूश
खजी खजी उशो जी वो सही दर जी okay, in order to define the tank in a WaterGem, so you should keep in your mind that the properties of the tank, that how you define the tank in a WaterGem. For example, this is a elevated tank. Columns are provided in order to support this on a ground. So basically here, if you give the value of elevation, basically this elevation we can get this by a TREX method. It's a TREX. The TREX is used in such a way that at a background we place a DEM file and other contours file, and by using this functionality or this algorithm, we can assign directly the ground elevation of their tank as well. It will automatically update this value. If you want, so what is that elevation? This is basically the ground elevation. This is basically the elevation at that point, elevation. So you can assign it at in a foot or in a meter depending upon your choice. If you want to change your unit, you can easily change the unit from here as well, the precision and the formatting, etc. If you want to give a base, what is the base elevation? So the base elevation basically this elevation base. If for example, if you want to design 15-meter elevated tank, so and the elevation at this point is, for example, is 650 foot. So and you want to design it up to the eh, 30 feet height of elevated tank. So you can do that just by giving the base elevation as 665 foot. Okay, the other property of to define the water tank is the elevation initial. Elevation minimum. So minimum elevation, we want to most design that the water level in a water level in a water tank should not be less than that level of or that elevation of water. So mostly we define a minimum elevation depending upon the condition greater than the base elevation up to 3 feet or 4 feet. For example, I am assuming that the minimum elevation from the base should be of 3 foot from the base. So if we want to design the elevation of minimum elevation, so we design it for we will be designing it for as a 668 feet. Another property is the elevation initial. So to define an elevation initial is basically when you start the simulation of a water in a WaterGEM. So what should be the water level at the start of a at the start of a simulation? The water level in a tank at the start of a simulation. So do you define that as well? We mostly keep it as the greater than the minimum elevation. For example, I am keeping this as the 675 feet. And the maximum elevation, so you just give the maximum water level up to which we want to design a tank. So you can keep it up to the 890. So it's a very big tank, 35 feet. So if you want to give the properties like that, so you, for example, we have a 650 feet of ground elevation and 690 feet of a maximum water level, and the initial should be of 675 feet. The minimum should be of 668 and 665 feet of elevation base. For example, if you want to define these levels of water in a tank, so you can also be defined as a level. So if you want to define it as a level, so you will have to define in such a way that you will define elevation ground elevation of the tank, and after that considering base is a 0, and after that you have to design the or the define the properties of that tank, the initial or the minimum, the maximum. So you can also define it by a level as well. Mostly the zoning is just basically we do it for our convenience. For example, if you want to design a tank for a commercial area, so you give it a name that it lies in a commercial area. So just like that, making a zones for the residential area or the industrial area or the commercial area. So you do that here for your convenience. Volume inactive, basically you in a million gallon is basically in a million gallon. You can provide it the water will be the volume of a tank. So and you can also here the installation here, the year in which year you install, for example, if you want to calibrate or you want to evaluate your model, so you should know about the you will have a bulky system in which you will have installed for example the start or the commissioning of your water supply network. You maybe you have installed two tanks or and after 3 or 4 years you install another tank in order to fulfill the demand. So you should know about the time at which you have installed, because if you open a model and you are working as a water supply engineer and you have designed a number of design water supply networks, then how you will remember that in each year that tank have designed and blah blah blah. So you should know about the installation year as well, because at the end you have to evaluate your system after 5 years, after 10 years, after 15 years. Even if you are working as a client in a PhD department, so you should know about that how uh, because you designed a water supply network through consultants, but in after if the consultant hand over the project to you, then after 10 years and 15 years the maintenance is basically you are doing the client mostly in our case, or you may also provide it to some contractor as well, but the maintenance responsibility is mostly the client, which he does for the water supply system. So he should know about the in which year he has installed that type of pipe or a junction, or for example also know about the at which year he has installed that type of tank. Similarly, you should also define the section of area. Circular non-circular variable is defined in such a way you can give here, for example, show you that if you want to define a tank cross section of like that you divide it in 100% depth. So for example, for a 10% depth, that percent of volume should be filled, and for a 20% of depth, that volume should be filled. So just like that you can define here the percent of depth and the percent of volume ratio. Has separate inlet. In separate inlet is working just like first of all I want to explain you that in mostly when we design water supply network in an intermediate system, for example, you are pumping water for some hour, and after that the design fulfilling by a tank. So if you design a water tank and only provide one inlet, for example here you have a pump house where you have a pump and you are pumping through a rising main to that tank. So you have only a one pipe filling a water tank. After when the pump house stop working, so again that then the pump start its own working and supplying the water to the network. But in case of a separate inlet, you have two different type of pipes provided in the pump, for example in an inlet pipe and outlet pipe. In an inlet pipe, for example, you may consider this P4 is a inlet pipe, and you want to pull it from a top. I will just explain it in a while. Inlet valve throttles, these are basically provided inlet water throttles are basically provided. That these are basically the check valves in order to provide the backflow of water through the pipes. Okay, so this is basically the level for the level which you want to provide the pipe at the top of a tank. Let me explain it here. سما سره خو نشته کنه جی وده شوی خو راته نه یې
No, ji.
It's okay, okay, sir.
Okay. If you want to define inlet, for example, two separate pipe for a design of water tank, so it will be just like, for example, one if you